All right. Hello, YouTube people. Let's go ahead and present what we're doing today. All right, this is the RTP-AWS. It's an independent group. We are somewhat affiliated. Oh, I thought I was gonna. I thought I had the. Let me see something since it's not there already. Uh, what's it called? GitHub. Let's do this. See if we've got. Let's go ahead and put this up here. Copy link address so that it will be there. CD. All right. And then if we go back. Thought I just updated that. Yeah, right here. Okay. Yeah, so the code of conduct for this group, it's be supportive to AWS people. Don't interfere. Follow the staff, and just be friendly. Whatever. Don't be a disturbance. And as a result of doing that, we can come back over here, and we can now close this. And done. All right, so that's done. Okay. All right, so now we're going to start on the actual work. Some stuff on Atom. All right, so we're over here on SageMaker. Let's start the runtime. Let's start it up here. Hopefully my code will still be up, and we can pick up where we left off. This doesn't look good. Okay, good. This looks better. And let's see if it's all the way to the end. Yes, okay, so we got everything here. All right, so a couple of things on this, if I remember correctly. Get average image from batch. So what we're going to do is we're going to copy this and take it. We're going to make it simpler. All right, so let's see if we can save notebook as. Simple. We'll just call it 001. Okay. All right, here we are. All right, what we're going to do is we're going to make this more like what we did before. We're going to cut out some of the stuff. Delete some of it. I think this will cut it. Yeah. Let's cut this out. We'll look at this. So put that up. Try not to have two sets of this. Path lib. OS is up there already. NumPy is not. Okay, let's just do like this. Control C. Got that. All right. We're going to cut this one. Just make sure it all works. Okay. We're going to remove this. We're going to remove this. We're going to remove this. This. Remove this. Remove this. Remove that. 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 Remove that. 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 Okay. It's about our transform. Okay, so we need the transform operation. So let's see what the transform. The transform, I think, was the average, but we don't necessarily need to do the average. So let's look at it again. Okay. So the original accuracy was 0.827. See what we come out this time. There's Num. Hello, Num. We're streaming.
Hello.
All right, so that lowered the accuracy, but
Yeah.
that's okay because this is just, we're going to experiment with this. All right, so let's see how this differs from the other one. Just kind of clean. We're just cleaning. All we're doing is we're going over the code for basic image classification using fashion NIST, fashion NIST sample data set. This is a simplified version of the example Glue on CV class Coursera. The original exercise normalized the data, did a 2-layer DNN, and then proceeded, then made the, then enhanced the example using convolution and pooling layers. The simplified version was process doing the exercise just the initial, just the DNN, normalizing the DNN, the input data is done in a second. Likewise, using convolution pooling is done in a third. Right, so that's that. All right, so this is install the stuff. We're going to do this. We're going to do this. That's the example. So let's explore. Okay, we got good. We got some of the stuff here. Transforms to tensor. And then rather than plotting this as this, I'm going to add in the CMAP again. Okay. So I don't know what he's trying to show there. That's the first image. Or no, that's the 123rd image. So let's print the label out like we did last time. Print the image label provided is sample label. It's probably just going to be a number. It's 4. Yeah. Okay. All right. From before, we know what the labels are. So let's put that label in. We'll use that same setup. Class names. Copy selection. We'll use the same. Okay. All right, we'll put a couple of, I will have to redo this a little bit. Code the class names as strings. And we'll move this up a level, move it up. They all like over here, one of the things I like about the collabs is you can move these things up and down. So like if I want to move that up, I can literally do like that and it moves it up, or I can move it back where you want. But over in these guys, they don't have that operation. Not so even if you right click, it doesn't. So you have to just drag it. But he's dragging it. I want to go right here. There we go. All right, so printing the sample label, we need to do test name.
Không. Không giật tay đặt cái giật đánh nó đánh có gãy cái mút hết sao?
That's a coat. Okay, so actually we need to move this up to here. We need to move this up. All right. Okay, so right here is what they were talking about. We took that out because we're not going to do that. Okay. All right. That's really kind of the same stuff. So that gets all of the stuff now. So now we've got it all. MXNet metric. Did I use MXNet metric? No, I did not. So this is interesting. The assignment said you're supposed to return a MX metric, a val metric, and I just returned the accuracy. So I may not even done that right now that I'm looking at it, and I can't remember how to do it. But then we're building a DNN, and units equals 10. I don't even remember what that is, so let's look it up. All right. MXNet dense API. All right, so what was it? What is this? Get rid of that. I don't even know what that's like an old one. It's TensorFlow. Let's get rid of that. All right. So glue on neural net dense. Is that where we got to? Glue on neural net. Yes, dense. Just your regularly. So we'll save this. So what is units? Dimensionality of the output space. Okay, that makes sense. So let's put a thing up here. We'll change it to Markdown. So explanation of minutes glue on and minutes. This is a single layer of 10 outputs. And they're going to calculate the accuracy. What we can also do is print the test network. You'll see it's just a single layer. Yeah. So basically, this little DNN here is going to take 784 inputs and then map it into 10 outputs. And he's going to use calculate the accuracy based upon the training data that comes in, which is the images and the labels. So this is really just it's already 10 minutes to go. This is a simple single layer DNN of 28 by 28 equals 768 pixel values and 10 outputs corresponding different image label classification. All right. And this is trying to say make sure your eval metric is the right. So the metric from calculate accuracy, which is this guy, is of MX. Yeah, right there. Okay, so that's it. So we put accuracy is that type, the eval macro. Okay, so that's good. All right. And it's going, and basically what he's saying is for each one, you're going to update the accuracy based upon what the prediction value was and the label. And so that's what's going on there. That's just a check. We can get rid of this. All right. In this section, you'll implement a couple of different image classification. The train function is already provided because the focus will be on network construction. So this is the training. SGD, I think, is sigmoid. Let's look at this API here. So MX Gluon trainer. So if we're in Gluon, go to trainer. Right, that's where we're at. Yep, we want to look at the second parameter. That's the optimizer. Simple gradient descent. That's what SGD is. Okay, I should have known that. So that's an example. He's not saying what SGD is. He's showing you how to build them. Let's go down. Like MXNet, I'm telling you, you've got to know your math to know what you're doing because it's not as intuitive as the other one. It just says optimizer. See help. And that's just that. I think that's the same place. Let's go to this one. just okay. Here they are. So where is SGD? All this, and it doesn't tell you what SGD is. I'm pretty sure it's simple gradient descent. There, when I say rescaled grad, I think that's gradient. There we go. Clip gradient. I'm just looking at it in there. All right, very good. So here, this guy, let's go to this one. Let's save that.
It's only a few minutes. Maybe we can go for the next week.
Yeah. Yep. I'm just gonna make a reference here. SGD possibly put this down. All right. This is 3 layers, 16 hidden layers, yada yada yada. And we did that and we printed it out. The thing that's, the equivalent here between what we did in TensorFlow over here is we printed out, like over here, we printed it out, the layers. And what's interesting is the very first one is like a 28 by 28, and then he generates a 784, and then 784 goes into the next layer, comes out 128, and 128 goes into 10, and we kind of printed it like that, right? With MXNet, you can just say print the network, and it'll do the whole thing, and here it will show you the input, the output, and the activation type, but it doesn't show you the input because they don't specify what the input is. They let the data come in, and based upon the data, it will determine it. So like, I think later when we print it out, we print it right here. So when we print the network this time, he literally says it's a 784 goes to 16, right? Here it's none to 16 because it's just a network. It hasn't seen any data yet. So it's a little, the whole point of this is all of this makes like a flow network. The data comes in and comes out. So yeah, I'll save this, and it is simplified. So the results here are similar to what we did here, except this has just got one intermediate layer, and this one has 2 intermediate layers.
Mm-hmm.
Oh, my eyes are tired already just coming back inside and looking at this screen.
Did you stop recording?
I will stop recording.